Tell me what a quadratic is. Who remembers what a quadratic is? 4. It sounds like there should be 4, but there's not. But it does sound like there should be. Anybody? Quadratic? Y'all remember? No, clearly not, judging by the crickets that are occurring as I. All right. So a quadratic has the highest exponent that it has is a 2, and it looks like this. A, B, and C being coefficients here, they can be any number that you want. I could be missing the B or the C. I could be missing any of those. But this is a quadratic in what we call standard form. Now, it's in standard form because it goes in order from its biggest exponent down to just the constant, okay? So that's how we know it's in standard form. Do y'all remember doing this now a little bit? Okay. So I could have things like 2x squared plus 3x minus 5, and that is indeed a quadratic. It's got the highest exponent of 2, comes down to the constant, but remember we could be missing a few, so maybe I just have x squared minus 7, and that is also a quadratic. If I've got that power of 2 there and nothing bigger on the x, then I'm a quadratic. Is everybody okay? All right. We will do plenty with these quadratics algebraically, but today we are just looking at graphing them. So when I graph a quadratic, what does it look like? You're exactly right. You're exactly right. It looks like this, right? You know what we call that? A parabola. Somebody said it. It's a parabola. That's right. When we graph a quadratic, we get a parabola. If I go too fast, tell me. Sometimes I get excited and I start talking really fast. And so a parabola can look like this, or it could also be a sad parabola and go upside down and look like this. Before we actually graph, let's talk about some things we know about parabolas. There's two really main things that I want you to remember and recognize about parabolas. Tell me what you know. Anybody? Think geometry-wise. What's special about a parabola? Starts with an S. It's symmetrical. What does symmetrical mean? That's exactly right. Y'all are all right. There's a line that cuts it down the middle. You can fold it over. It looks the same. It's exactly the same on two sides. So it has this, I'm going to actually call this an axis of symmetry. We'll use a little bit better terminology here, but they all have an axis of symmetry, which means they're exactly the same on either side of that axis. Then there's one more very, very important part of a parabola. Do you know what that is? It actually goes hand in hand with that axis of symmetry. What is this called? Vertex. That's called my vertex, okay? It is the highest or the lowest point of a parabola. It gives me a minimum or a maximum. And this is all going to be important as we start to graph. Everybody okay? A little background on quadratics. Too fast, too slow, just right? Y'all got to tell me something. Just right. I heard just right. Miles, just right? If you go into Canvas and you look under today's, it'll say notes. Yep, you see it, note standard form. So that's all well and good, but my goodness, how am I going to graph these parabolas? I'm glad you asked. I'll be happy to tell you. Actually, I'm going to show you one more thing before I do. Is that a quadratic? Yes. Is it in standard form? How do you know? Biggest exponent all the way down to the constant. Very good. I think about that standard form, ax squared plus bx plus c, tell me what a is here. -1. Drop the variable off. We're just looking at coefficients, right? Even though it's not there, that negative in front makes that -1. How about b? +2. How about c? -5. See if they make it.
Pardon this interruption. At this time, last names K, L, and M students needing a device only. If you have a device, do not come. Only those needing a device, please report to the library to pick up your device. Thank you.
That -5 that's on the end. Let's see if anybody knows this. That -5 is important because it represents something graphically. Does anybody know what that might be? Not the vertex. It's a good guess, though. Yes. I'm impressed. How did you know? Was it a guess, or do you know? The y-intercept. The constant on the end gives us the y-intercept. So let me rewind just a little bit because I never like to just tell you something without telling you why it is what it is. But I feel like it helps you understand a little better. How do you find a y-intercept? If you just have an equation, you put x is 0, right? What happens if you plug a 0 into a quadratic equation? 0, 0, what's it leave? The number on the end. That's why the constant is always the y-intercept. Okay, does that make sense? All right. So we've got the y-intercept. We can look at this way, and we can tell the y-intercept. Now, I don't know how far your Algebra 1 teacher got as far as transformations and things like that. I'm going to assume they didn't get far, and I'm going to tell you this. If your number in front, so if my a, okay, this is just dealing with the a is going to tell us a lot about the way the graph is going to look. If a, now if I say greater than 0, what does that mean? What kind of number is greater than 0? Positive. If a is positive, then I'm going to have a happy parabola that opens up. But if a is negative, so less than 0, what do you think is going to happen to my graph? Upside down. It's going to be a sad parabola, right? It's going to open down. Everybody okay so far? Yeah. Yes. Where did the extras go? There you go, Mom. Is there just one extra? Well, yeah. All right. This is the part that's kind of hard to wrap your brain around, so stay with me. What do these symbols mean? Absolute value. What's absolute value mean? Just make it positive. Whatever it is, make sure it stays positive. As the absolute value of A gets bigger, the graph itself gets skinnier. It does the opposite of what you think, okay? And I'm just going to tell you here, when A is just 1, that's a standard normal graph. Sometimes we call a parent graph the width of the parent graph. So we're always comparing to 1. So as that A gets bigger, it literally shrinks in that graph. So if I had 5x squared, that's going to be much skinnier this way, okay? Now, in the other direction, if the absolute value of A gets smaller, and you might say, but wait, how is A getting smaller? Because I'm talking about absolute value, and it can't be negative. So what am I talking about here? Fractions, that's decimals and fractions. That's exactly right. 1/2, 1/3, a quarter, a fifth, all of those. As A gets smaller that way, what do you think is happening to the graph? It's widening up. That's exactly right. Getting wider. So a big A might give me a teeny small little width graph, but a small A would really widen that parabola up. It still has all the same things that the parabola has. It's got the vertex, the symmetry, all of that. Just it's dealing with the width. Y'all okay there? All right. I'll give you just a second to catch up with me before I show you an example. A lot of background on this one. Yeah. 0. So positive. So this means A is bigger than 0 means positive. Sorry, I explained that whenever you were out. And A is less than 0 means negative. No, no. Let me go back. Let me go back and let you copy these. And then, all right, so here's my standard form. I'm going to just tell me what you know about this parabola. The y-intercept is -1. You're exactly right. I know without even graphing this, I haven't done anything with graphing, but I know that the y-intercept is going to be -1. It's going to cross the y-axis at -1. No matter what else it does, I do know that. What else do I know? It's what? It opens down. You're exactly right. It's a sad parabola because it goes down. Because of that negative in the front, right? That negative right here in the front tells me that it opens down. What else do you know? Close. Skinnier. It excuse me, it always says the opposite of what you think. Since 3 is bigger than 1, then it's going to be skinnier than the average one, right? So this 3 is making me get skinnier than before.
Excuse the interruption. Students with the last names N through Q, if you do not have a device already, please report to the library to pick up your device. N through Q.
I should have done this first. What is A in this equation? -3. What's B? 4. And what is C? You'll see why I'm having you do that because we're going to use that in just a minute with our vertex. All right, una más. By the way, if I write this way, does that confuse anybody? That just tells me that it's a function. Oh man, I didn't want to do that. Wait, I want to do that. That just tells me that it's a function. Remember that mapping question we had on Kahoot yesterday with one and only one output for each input? This just tells me that it is a function. It does meet those requirements. It's just a way to name it. It's the same thing as y equals. F of x and y equals, those are the same thing. We'll get more in depth with that. But if you see that come up, that means the same thing. Is this a quadratic? Yes or no? Yes. How do you know? Highest exponent on the variable is 2. Okay. I'm missing something though. What am I missing? I'm missing B. But really B is still there. You just don't see B. A is a half, but it's 0. You're exactly right. B is 0. What is C? -3. Does this parabola open up or down, or you have no earthly idea? Remember, I'm looking positive or negative, right? Positive is happy, negative is sad. So he's a happy parabola, so he opens up because 1/2 is positive. Skinny, wide, or average? Why? 1/2 is smaller than 1, which widens it up. The smaller it gets, the wider the graph gets. So this is a wider than average graph. You know one more thing about this graph. What is it? -3 is the y-intercept. Give me, yeah. Nope, that has no bearing. It's the absolute value of it. Yeah. That's okay. That means it does this. If A, you're looking at A for up or down. A tells you everything except that y-intercept. A tells you up or down, skinny or wide. Yeah. A. The absolute value of A. As A gets bigger, the bigger A gets, the more it makes that graph just skinny. The smaller A gets, like 1/2, 1/3, 1/4, the more it widens it up. No, skinny wide has nothing to do with negative. That's positive or negative. That's exactly right. Yeah. Wide. Yeah. Then it's right. This one's going to be wide. If it's a whole number bigger than 1, yes, it's going to be skinny. If it's 1, it's average. That's your average one that you have. A makes it upside down or right side up. Positive or negative. Okay, I said uno mas, but let's do uno mas because I can tell you need one more. All right, let's say f of x equals this one's different. This one's a little bit harder. I tricked you. I tried to trick you anyway. Yes, it's down, but 5/3. Is that making it skinny or wide? I hear both. It's bigger than 1, so it's skinny. Yeah, yeah, I know, I know. You knew it. You knew it. You just right, right. Y-intercept. I know you did. I believe you. You don't remember what? I don't know. All right, give me a thumbs on just looking at it that way. I got it. So, I ain't got it at all. Okay. All right. Oh, you meant that? Okay. Okay. All right, then let's graph. Because it's easy. We can look at it. We can tell what it might be. Y'all need a break before we graph? Okay. Let's take 2. Stand up and stretch if you need to. All right. Let's graph then. We talked about all those different characteristics. Let's actually graph them. So what I think I will do, on the back there is an example that runs through everything. I think that I like a step chart if there's any time that I can do a step chart. So I think I'm going to do you a little step chart. If you want to put this in, even if a teacher gives me notes that are already printed out, I have to write them because it helps concrete it in my head. That's just the kind of learner that I am. So if you want to copy them or if you just want to follow whatever you want to do, I'm going to do a little how-to chart graph in standard form because this is, remember we talked about standard form and it looks like that with the biggest exponent down? Just like a line, there are multiple forms of a line, right? You got slope intercept, point slope, standard form of a line. You got different forms that a parabola, or excuse me, a quadratic could be. So this is standard form, and we will talk about all 3 forms, the other 2 on Monday. All right, so I think what I'll do is I'll put your steps on the left, so it will pretty closely follow the steps on the front of the sheet. This is just a quick guide too that you can have in your notes that You don't remember. And then on the right side, I'm going to run that exact same example along to show you as we go what each step looks like.
Pardon this interruption. All students R, S, and T and do not have a device already, please report to the library to get your device. Thank you.
Sorry, y'all. I'll give you just a second to catch up with me. Oh, that's a lot of y'all. May the odds be ever in your favor. I'm just kidding. No, the first, I'll put a number 1. This is just the example that we're doing, and it's in standard form. So step 1. All right, so the first thing, before we even do a step, let's do what we know. Tell me without graphing, without doing anything else, what do we know about this parabola? Up or down? Oh, down. Why is it down? Doing the example over here, sorry. Down. Down, down, down. The negative in front. The negative in front makes it down. I said, oh, it says positive. That's your y-intercept. That's okay. It'll come. It'll come. All right. I'm down. 7's my y-intercept. Skinny, wider, average. Average. The absolute value of A here would be 1, and 1 is my standard. That's what I'm always comparing. It's going to be a normal average width parabola. All right. Are we okay so far? I don't believe you, but we'll do another example in just a minute too. It'll take me the longest to get through the first one because I'm explaining steps as I go, so don't look at it and go, how do you expect us to do this on our homework? Because it took you 20 minutes to get through one. Well, that's because I'm explaining too as we go, okay? And you'll see I'll do another one. Not that y'all talk like that, but anyway. Okay, shut up, Stacey, and let's just keep going. All right, the first thing I'm going to do is let's list A, B, and C out. And this is going to help us as we go through and do our graphing. So in this case, what is A? -1. That's exactly right. What is B? -2. What is C? +7. Is anybody confused on where I got those numbers or what in the world is going on? Step 2 is the hardest step. So stay with me, okay? Y'all ready? You're like, it's all been hard, just stop. Okay. Next thing we're going to do is find what I think is probably the most important part of the parabola. If I told you to find the most important piece of the parabola, what would you think you would be finding? The vertex. That's exactly right, and that's what I'm going to find. So step 2 is to find the vertex. And to find a vertex, remember a vertex is a point on the graph, right? And every point on the graph has 2 parts. It's got an x part and it's got a y part. Do you agree? Okay, I was going to say yes because that's right. All right, so it's got an x part and it's got a y part. Now let me stop here for just a minute. If you find the x part of anything on a graph, how do you find the y part? You plug it into the equation. That's exactly right. This equation says y equals. It tells me what y is when x is a specific value, right? So if I have an x and want the y, I just plug it into that equation. All right. So how in the world am I going to find it? This is where you have to remember a little bit of a formula. We're going to first find the x part. And to find the x part, we're going to do opposite b. Notice I said opposite, but I wrote negative, okay? The reason I do that is because if it's already negative, it can throw you off if you remember it being negative b. So it's opposite b over 2a. This is technically an Algebra 1 standard. You could have done it. I teach it as if you've never seen it before because Some of us haven't, but some of us have. All right. This is also going to be my axis of symmetry. Because remember, it goes straight through the vertex, okay? So I'm going to flip over to my example side, and I'm going to say, okay, let's find first the x part of the vertex. So for my vertex, x equals, well, what's the opposite of b here? Positive 2. 2 over, and then I have to do 2 times a. So 2 times what? Negative 1. Everybody okay? Which is 2 divided by negative 2, which is now that is what we're going to plug in. So the second half of step 2 is we're going to plug in to find y. What am I plugging into? I'm plugging in back up to that very top equation, whatever I started with. So for this one, I'm taking it and I'm plugging into the equation. So y equals, now be very careful because this negative sits outside here, right? I've got negative, and then whatever I'm plugging in, I put in parentheses. Minus 2 times negative 1 plus 7. Uh-oh. Order of operations take over here. Negative 1 squared is positive 1, but that negative outside forces it negative. So I get negative 1 minus negative 2 plus 7. All right, is everybody with me? What are the, yeah, like that? Is that good? What are the coordinates then of the vertex? Negative 1, 8. So here I'm going to put a note that says, so I can go ahead and plot that vertex, right? All right. So I am going to come off to negative 1, 1, 2, 3, 4, 5. No, there's 3. 4, maybe 5. I don't know. I sit around every time I do it. All right. Negative 1, 8. That's also my axis of symmetry. So if you want, this is not a necessary step. Sometimes I'll just do that so I remember that's where my line of symmetry is going through. Or maybe I just put a V here so I remember that that's a vertex. I don't want it to get confused with any of my other points I'm fixing to do. Everybody with me? Step 3. I'm going to say find an easy point because I think that's how I referenced it on the sheet. Now, what do I mean by an easy point? Parabolas go up really, really quickly or they go down very fast, right? Because if you think about the way a parabola looks, if I'm right here and I come all the way over here, look how high up I'm going to be, right? So easy point, what I really want to do is stick close to the vertex, okay? Now, stick close to vertex.
Please pardon this interruption. At this time, all seniors report to the auditorium. If you are a senior, you should report to the auditorium at this time. Thank you.
I want to stick close to the vertex, or this doesn't always work, or use the y-intercept when you can. Now, it could be that the y-intercept is like 25 and it's not feasible for you to graph 25. Or it could be that the vertex and the y-intercept are the same point and you got to have another point. So there are times when it works and there are times when it doesn't. You can always stick close to the vertex though. So if I look back at my example here, I need an easy point. I could use the y-intercept on this one, right? What did we say the y-intercept was here? 7. That's pretty close to 8. I wouldn't have to go over. Or I could pick, maybe I let x be 1 or whatever it is and plug that in. Now for the case of this one, I'm going to use the y-intercept of 7, and that's what I'm going to use, because if you can ever use it, save yourself the time and use it. And that's right there. Everybody okay so far? Okay, one more step. And there's not really math involved with it. It's my favorite because it's catchy. Step 4. Yeah. EP for easy point. Because my parabola is symmetric, meaning it's the same on both sides, I'm going to take that easy point that I found and I'm going to reflect it, and then all I have to do is to connect to graph my parabola. Reflect and connect, that's why it's my favorite, it's catchy. Do you remember how to reflect a point? If this is my axis of symmetry and I'm reflecting that green point over, what do I do? Count. You just count over. It takes me 1 to get there, so that's how many I go over in this direction. And there is my ever so beautiful parabola. It seems like a lot, doesn't it? It seems like a whole lot. Here, I'll zoom out. This 1/2 because, and I'm doing it for, there's a reason that I'm doing this one. So it's y equals, of course, it could be f of x. That's the same thing. 1/2 x squared plus 2x. Tell me what I know before I do it. It's wide, it's up, and the y-intercept is 0. All right, let's go for it. What is A? How about B? How about C? Ooh, nice. Okay, so first things first, vertex. Remember, I need to do x first, and I have that little bitty baby formula to find x. Opposite B over 2A, and since I listed out A, B, and C, it makes that really easy for me, right? So x is opposite B, which is -2, over 2 times A. That's right. Okay. Remember your order of operations, multiply those things in the bottom first and then divide. So I end up with -2 over, what's 1/2 times 2? 1. So the x part of my vertex, which is also known as the axis of symmetry, is happening at -1, right? All right, so here's -1. Also my axis of symmetry. I need to find out where on that axis of symmetry that vertex falls. So how do I do that? How do I find the corresponding y value there? Plug it in. That's exactly right. So I'm going to plug it into that equation. So y is going to equal 1/2. Again, whatever you're plugging in for x, put it in parentheses because it will help you. So I've got -1 squared plus 2 times -1. Yes? All right. I get 1/2 minus 2, which is what? 1/2 minus 2. You have 50 cents, but then you owe somebody $2, so you really owe how much? $1.50, so -1.5. I always relate to money because, whew, one thing I don't have enough of. All right, so 1, there's 2, so here's negative 1.5 right there on that line. All right, I need an easy point. Instead of using the y-intercept this time, let's pick an easy point and let's see what happens so you can see how you still get the same thing. It still works out to be the same. So for my easy point, I want to stick close to negative 1. What's close to negative 1? 0 or negative 2, right? I'm going to use negative 2 since I opted not to do the y-intercept. Let's say negative 2, and let me show you how this works. Now this one, y'all hear me, this one would be easier to use the y-intercept, and we're still going to have it. I just want to show you how there's more than one way to do it. So here, if I put negative 2 in for x, then I get 1/2 negative 2 squared plus 2 times negative 2. Exponents come first, so I've got a half of what's negative 2 squared? 4. What's half of 4? 2. So this is 2 plus negative 4, which is, there's a whole lot of basic arithmetic is what
Pardon
happens.
this interruption. Any students that have not received their laptop with the last names letters A through K, please go to the library right now to receive your laptop. A through K, all students.
All right, so my vertex is negative 1, negative 1.5. My easy point is negative 2, negative 2. Yeah. Do what? Did I make a mistake? Did I make a mistake somewhere? Because this was it. Where are y'all looking? Where did I mess up? Please always say something. I start going so fast and I get so excited. This has got to be over 1. Bro. I dropped the ball on that example. Oh, it's only the second day though. All right, do y'all see where I messed up? Y'all just let me keep right on going. Yes. Okay. All right. So everybody sees where I messed up on the vertex. Negative 2 divided by 1 is negative 2. It is definitely not negative 1. So that's going to make my y wrong because I plugged the wrong thing into y. So this is 2, which means this is 2 minus 4, which is negative 2. I just found the vertex twice here. Golly, I'm sorry, y'all. Yes. Now, yeah. Now, easy point, because a lot of you are getting confused on easy point. All right, so let me take some time to talk about easy point. You can always use the y-intercept, until you can't. Unless the vertex sits on the y-axis, and then you can't. Now, there are times when it's not beneficial to use the y-intercept. In other words, what if the y-intercept was 50, right? And what if I had a vertex of negative 2, and the y-intercept was 50? I wouldn't want to go all the way up to 50, right? I'd want something a little bit closer, a little bit easier to plot. So what I do is I look at that x part of the vertex. In this case, negative 2, right? And I'd look at something really close to negative 2 because I want to stay close to that point. What's close to negative 2? Negative 1. I'd probably pick negative 1. I'd probably stay right beside it. Then think about it. This is the way a lot of you see this. Think about it like this. I'm plugging in -1. What am I getting out? So if you plug that in, 1/2 -1 squared plus 2 times -1. There's my -1.5. Bro, I can't believe I did that. Does that make sense? Do you understand why I'm talking about an easy point? I call it an easy point because it's easy for me to plug in. It's easy for me to plot. It's easy for me to go in to find close to the vertex. If easy point confuses you, just pick any x you want to, because it can be anything you want it to be. It's just easy to stay right beside the vertex. Because in order to graph a parabola, I need 3 points. I need the vertex, some random other point. It doesn't matter what this point is. This is the point that I'm going to reflect and connect to find the third point. And you need those 3 points. So the easy point is finding me that second point outside of the vertex. And it can be whatever you want it to be. -1, -1.5, reflect, and connect. I'm going to do another one with you, but this one's going to be off your homework. So we'll do a homework together. I tried to do problems from your homework with you so that eliminates some of that also. Pick one, 1 through 6, you pick one you want me to do. 5, I heard 5 first, so 5 it is. I'm going to guess there's probably a fraction in 5, and I haven't even looked at it. Numero 5. My Spanglish. 1/4 x squared plus x minus 6. Tell me what you know. What do you know? It's going to be wide. Y intercepts -6, and it's happy. It's happy. Okay. Let's find the vertex first. How do you find a vertex? Formula. Oh, I should list my A, B, and C. What's A? Yep. What's B? What's C? And it's a happy. Yep. It's definitely happy. Happy and wide. All right. So x is opposite B. I'll write that little formula here for you. Over 2A. So the opposite of B would be what? -1 over 2 times, what's A? 1/4. Now, if you're not good with fractions, do better. I'm just kidding. Okay, so I've got a fraction in a fraction here. That is no bueno, right? I got to do something. Let's look at the bottom first. What's 2 times 1/4? A half. A half. That's exactly right. If you double a fourth, if you have a fourth of a pizza and you double that, then how much pizza do you have? A half of a pizza, right? All right, so I've got -1 over a half. Now, I'm fixing to say this, and you will probably hear me say this a gajillion and a half times before you leave here. Never, 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 never divide by a fraction. Instead, what can you do? No decimal. Reciprocal. Somebody said reciprocal. Multiply, but you're right. Multiply, put those two together, multiply by the reciprocal, okay? So I take the top and I multiply by the reciprocal of the bottom. So never divide by a fraction, instead multiply by the reciprocal. Reciprocal means flip him over, okay? Now what's -1 times 2? -2. The x part of my vertex here, which is also my line of symmetry or axis of symmetry, happens at -2. Is anybody confused? Everybody go with axis of symmetry, x part of the vertex. All right. That is not, however, the whole vertex, because I have to find where on this line it's happening.
Pardon the interruption. At this time, any student who has not yet picked up their device
We
or
just
put their
said
name on the
that.
list to receive their device at a later time, please come to the library and pick up your device at this time. All students who do not have their device and their name has not been put onto a list to get one at a later time, come to the library at this time. Thank you.
Welcome. How do I find where on this line I'm going? Plug it in. Find the y part, right? And to do that, I plug it in. So y equals 1/4 -2 squared. Make sure you find the x part right first, or you'll mess your whole problem up like me. -2 minus 6. Square that x number first before you multiply by a fourth. So you get 4. So I got a fourth times 4 minus 2 minus 6. What's a fourth times 4? 1, right? So I get 1 minus 2 minus 6, which is, wow, it took a long time to get there, -7. That's the hardest part of the problem. I've got -2, -7. That's exactly right. If I do everything correctly, I should be opening up and be wide. There's my vertex. Should I use the y-intercept, or should I just pick an easy point and plug in? I hear pick an easy point. Does anybody want to think that we should use the... I say we could. It's pretty easy to plot. Yeah, it's pretty close. It's on the y-axis. It's not a terrible number to use. I'm probably just going to use the y-intercept here. If you didn't use the y-intercept and you picked an easy point, what would you probably pick to plug in? -1. Why -1? It's right beside -2. It's close. In this case, my y-intercept's only 2 over, so I think I'll use it. It's -6. I think I'll plot that 1, 2, 3, 4, 5, 6. And then your very, very last step is to do what? Reflect and connect. That's right. Go over 1, 2. So keep going 1, 2. I reflected. Make sure this is not a V. It shouldn't be a V. That's an absolute value graph. Instead, it's going to be a smooth curve that connects around and goes on forever. Both directions. If you pick -1, you'd end up right here. It'd be the same. Still be the same. Questions, comments, concerns, what you think?